Guys, welcome to Beyond the Model, Series 2, live from San Francisco. What an awesome environment to be, and what an awesome guest to have on the podcast. So, just for anybody that doesn't know, Beyond the Model is a community run by the Strativ Group team and my team, which is for anybody interested in frontier AI of any kind, right? Whatever your background, if you're technical, you're a researcher, an engineer, or you have no technical knowledge, this is for you. This is where we talk about what's exciting, what's interesting, what's happening. I am absolutely honored, I would say, to welcome you to the podcast, Yanping. How are you?
I'm doing great. Thank you very much for having me.
It's a pleasure, like a real pleasure.
And welcome to San Francisco.
Yeah, thank you so much.
Weather today is very good, very nice.
Yeah, the weather is great. It's better than England. Yeah, lots better. Today we're going to be getting to know Yanping and his journey, and we're going to be hearing about him on a number of really exciting things. It's going to be a blast, and I hope you're all excited. So yeah, Yanping, why don't you just give a quick introduction of yourself, and then we'll go into more detail and get stuff.
Hello everyone, my name is Yanping. So I used to work at Google Brain, Google DeepMind for about 1 decade. And recently I quit Google to start my own company. So I used to work on mostly machine learning, deep learning. And especially I work on like large language model and the infrastructure, the training infrastructure, server infrastructure, the training recipe, pre-training and post-training of it in the past 8 years. So yeah, it's very great. Like, thank you very much for the invitation. I'm super happy to be here.
You've had a really interesting career, man. Like you really have, and I think we're gonna get to the bottom of it today. Okay, we're gonna get to know you as a person.
Yeah,
because I think it's a strange time to be involved in AI, right?
But AI has been here for 50 years already. It comes up and down. There's I think in 2008, there's AI winter. So anything you said about neural network will get lower at certain rates in major conferences in user learning. So at that time, neural network AI is a bad word.
Yeah, and now look at us. But yeah, so Yanping, I think one of the things that we've been talking about a lot, right? And this is going to be, I'm going to learn some stuff there about you. But I think one of the things that's really interesting is your journey to, and because you ended up, right, and please feel free to tell people, but you ended up as a director, right?
Yes.
At DeepMind, and that was quite a senior role, right?
Yes. So director level is kind of there are about, when I left, about 10,000 director levels at Google. So it's kind of it's not executive level. Yeah. It's at least middle range management level.
I feel like this is a little bit humble. So it's just so impressive. And so why don't we go back to where it starts? Why don't you just tell us about the journey? How did this all happen?
I was raised in a middle class family in a small city in China, Quanzhou. But it has been a city for 1,500 years. Yeah. So people there doing business, doing commercials. They are not interested in education or studying. For the 1,000 years, but for all my families, my relatives, they're mostly small and medium business owners. Mm-hmm. They sell diapers, they sell underwears, they sell whatever makes money. And I think, but for my parents, they are they are the first college students in the family, and so that's the direction I'm going towards. So after high school, I would go to the universities in China, and after I graduated there, because every good students would go abroad at that time, around 2005, and then I do the same thing. I just follow their path. Yeah. But for me, I'm interested in physics. Yes. Because I major in physics. Yeah. But for me, it's too hard to study string theory or those very classic or quantum mechanics. At that time, there's a workshop at Beijing that offer free hotel, free dinner, organized by some of U.S. institutes. And I attended there all about complex systems, like chaotic systems. They're trying to build a model for like multiple particles. Because comparing to the particle physics, they study a single atom, single particle. People are interested in like very complex system, how they interact with each other. That's how I get very interested in the human brain. So I want to study this direction. So I go abroad to study computation physics. And one of the special area in computation physics would be computation neuroscience. And that's how I get into the whole AI world. So we want to understand the human brain, how human make decisions, how human thinks.
One of the things that's really fascinating is I read a book recently. You may know it. It's called The Alignment Problem. And the book is basically, it kind of chronicles the history of AI, if you will. Right? Yeah, but it goes all the way back to the like the 1950s, right? The 1960s. And he, obviously, you will know this in detail, but how like psychologists, I guess, and neuroscientists at the time were talking about, neural networks, basically.
Yes.
Like, a long time ago, right?
Right.
And yeah, so it's really cool, like this whole day of how the brain works, AI, everything kind of comes together. But yeah, okay. So what did you actually study during your PhD? What were you looking at?
It's quite a journey because I spent like 10 years in my PhD.
Oh.
I changed different subjects. First, I was in computational physics.
Yeah.
And I've switched to biophysics / computation neuroscience. And then I finally moved to computer science, artificial intelligence. So I was young, like I was like 20s. I don't know what to do. And I have like little information about how the society work besides in university. I don't know about the job, the work. I just want to follow my like curiosity.
Yes, exactly.
And I mean, thanks to the scholarship from like US government or the university, the public schools, I can do whatever I want.
And then you can do whatever.
And forever. Like if you want to be a PhD student forever, you can do it. They have like scholarship. They have like $2,000 to pay your rent, right? And you can eat at the school, and then you can have insurance. And what else do you need? You just study or do some research.
I mean, that's a good deal, by the way. Like, that's not bad. Because when I went to university, I had to pay, and this is a whole other side topic, but in the UK, I guess in the US as well, but you have to pay a lot of money to go. So as like a curious scientist, right? As a researcher, being said like, we'll help you do this, and then you can pursue what you want.
But there's like a gap between what I imagine what is important and what people really need. Like, and it's kind of like you are in the ivory tower for too long, and you don't know what insurance means. Like,
yeah, I mean, we're going to talk about this later, by the way. Like, we talked about this the other day, didn't we? Where with clients, right?
Yeah.
And this goes for any job, for my job, for Yanping's job, for lots of people. But what clients want, what they need, sometimes very different, right? But
and what we imagine what they want and versus what they exactly want are totally different things.
Oh, totally. But okay, so you came to do computer science. How did you what AI and computer science? Like, why did you go to do those?
To be very honest, it pays better.
Totally valid.
Yeah, the graduate students from computer science pays much better than the other subjects. Yeah, that time.
Yeah, absolutely. When did you graduate your PhD?
2014.
2014. Was it before ResNet or?
Before, but around the time. Because when I doing a PhD, neural networks start to take off.
Yeah.
Especially after 2021, 2022. Yeah. Sorry, 2011, 2012.
Yeah. I think there's like 3 crazy times to study computer science. One is like, 2010 to 2014.
Yeah.
The other is maybe like 2016 to 2018. So attention.
Yes.
Which people talk about. And then the other is 2021 to 2023. Maybe now, GPT, right?
Yes.
So those are like the, did you, I ask a lot of people this, but did you know when you were studying that this was going to be huge?
No, I didn't know about that. Because the first job I got after my PhD, I was working on like the music app. So we have like YouTube to organize the music.
Google?
That's Google.
Okay.
So just like music videos, we turn it into some Spotify like app for people to use and charge some premium money. That's something like I enjoy doing it, but it's the first time I get to know what product likes. I do it for like 1 year, and then I figure like I'm still a researcher.
Exactly.
I need to do some research. Then I joined Google Brain, and that is a fun time. It's just like you go back to graduate school again, but with much better pay.
I mean, do you want to talk about that? I tell you what, I think people might be interested in hearing about. Talk me through how you got the job at Google. Like, how did that happen?
So it happened naturally because I graduated from University of Washington, which is the top CS school, top PhD program. So we have a lot of choices when we graduate. Google is, I think, at that time, it's still a very hard company. Like many students want to join. I think it's still now.
Still now. Yeah. But why did you pick Google?
It's just kind of a random choice, to be honest.
Did you have like lots of good choices? And it was like,
I have like, for example, Quora.
yes,
It's very hard to get in at that time. Maybe Dropbox.
Yeah, Dropbox. Yeah, wow.
And also some stuff like Genifix.
Yeah, wow.
And cool stuffs.
Yeah.
And maybe Uber, I don't remember.
Yeah, wow. And okay, so you joined Google. What was your first like? What were your first impressions of working there?
So there are a lot of smart people around. Because like at that time I have like, because we do a lot of paper from Google, and at Google we have a chance to meet with them and work directly with them. So it's such a, I think it's a very good opportunity for new graduates to have conversation, to collaborate with those work experts in AI field. Yeah. And at Google, it's not just like they can publish good paper, but they have like real production impact and real impact to the ML community.
It's like some of your papers have had some really big impact as well. And
thank you.
Yeah, they are. This is like objective, right? Like, you're welcome. So Google Brain, right? When did you actually join Brain?
2016.
2016. What was it like in 2016?
It's about 100 people.
Yeah.
And we are working on something from the very bottom, infrastructure work. TensorFlow, the framework to build neural network, to applications to search, to add those product areas in Google. So, and then we just like 100 people each. And there are a lot of very original, interesting, groundbreaking work was done at that time.
Yeah, really.
Like word to web. So you want to map a word, an English word, to some vector space where you can use neural network or mathematics to manipulate those words, sequence to sequence, so that you can predict the next token and like bring up the whole area of language model and transformer, etc.
Yeah. And the attention transformers, it all comes from Google Brain, right?
Yes.
Yeah. Wow. So you were at Google Brain for
8 years.
8 years, and then did you get reorged into DeepMind?
Yes.
Yeah. Okay. What was that like?
I think it's a wise move from the leadership, right? Because otherwise there would be so many groups in Google doing similar things. Yeah. So that happens before the merge, because like there are literally 3 groups trying to do the same language model, and after merge, it's fortunate that Google has only a single effort working on this direction. Yeah. So I think it's a very good move by the leaders.
Yes, a good move by the leaders for sure. Makes sense. Somebody once referred to me. It was actually somebody who still works for DeepMind. They still work there now, but they referred it to me as the alphabetization line, which is interesting, right?
Yeah. So it's from different perspective, because from original DeepMind people, they were free to explore a lot of like scientific aspects, not product aspects of machine learning. So they would do AlphaFold, AlphaGo. That has nothing to do with products, right? Yeah. So it's the long-term bets for alphabets. I think for Google Brain, we focus on deep learning and neural networks, and with special focus on a lot of applications like search, ads, YouTube, recommendation. It's kind of like we are more product oriented than the DeepMind people. So it's kind of like it was quite a cultural shock for both teams at the time of merge.
A lot of people have said that to me. Like we know quite literally hundreds of people from Brain and DeepMind, and the reality of it is a business has to. GPT changed a lot of this, right? OpenAI changed a lot of this, and the business has to make money, has to make revenue.
Yeah,
right?
the business has to survive.
Yeah, really, and you have to justify, right? Why you are employing thousands of like really well-paid researchers to do like you have to, right? But that makes sense. And I have another question as well, which is about some of your work on especially like the scaling for Tensor. What was the first like big paper you were involved in?
Around 2017, I was working on ImageNet because ImageNet was the holy grail at that time. Everyone trying to compete for SOTA. So we came up with some way to do architecture search with various algorithms, so like we can use machines to discover an architecture that is better than the human design ones. So we need to make models small so that we can iterate very fast on those candidates and then find the best one. And then we scale up the model to get the SOTA. So during that process, we found that it really doesn't matter what the architecture detail would be. It's the size that matters. And the bottleneck at that time would be the memory constraint of GPU, which is 8 gigabyte or 16 gigabyte. It's very small, very tiny. And that is usually what the largest model can support. And people are still working on like, how can I design better algorithm, better architecture within that constraint? And we realized that why not just break the bottleneck, just keep increasing the model size to whatever it is, whatever we can support.
Wow.
So that's the first GPipe paper. So we try to break the neural network into pieces. And then each pieces would be on different GPU or TPU. And then we pipeline them together so that it can run efficiently.
Wow.
So I think it was like one of the earliest work to do model scaling, like algorithm. And we did it. Like, so we scale up the ImageNet model to like 10 times larger than smaller ones, or the biggest one previously. And we get a very good result. The new CFR in ImageNet, in CFR, in all those ImageNet, all those image classification tasks. And the record was kept for like 1 year.
Wow.
Because like no one else can do this kind of scale.
That must have been awesome.
Yeah. And at that time, Google is a text company, and all our applications, so when we publish paper, it's not enough in Google Brain.
Yeah.
You need to show impact.
Yeah, you need to
show that people really use these papers.
Because otherwise, why are you doing the papers, right?
Yeah. Otherwise, you will be in universities.
Exactly.
So the common application we look for would be just translation, because translation was important for NLP during that time. It's kind of unsolved problem. How do you do universal translation for any arbitrary pairs of languages? Then we also apply this kind of scaling to translation. And we found that if we have multiple language training together, and by making the model bigger and bigger, we can have tremendous improvement over all the language pairs.
I don't know how many times in total your work has been cited, but I believe it is more about 20,000 more maybe, or something like this.
Yeah. For all the paper combined.
Yeah. Like more, which is crazy, right? Like so the first one, that would have been one of the first ones. What was the title of the paper? That paper?
GPipe paper. Yeah, I think that's the first pipelining parallelism model paper. Such model at the time. And there are a lot of follow-up to make this kind of parallelism better and better. And nowadays, I feel every company use that.
That is crazy. Yeah. So that's impact.
That's impact.
Yeah, that's like real impact. And what was it like producing a piece of work that so many other people were interested in, like both scientifically and maybe commercially? What was that like?
You want to be innovative and having a large impact. Yeah, at the beginning, it would be lonely and controversial. Like, no one would believe in you. So because we want to make model bigger, and people said, that's too expensive. that's not affordable, and that's just mechanical, right? And because like everyone believes that if you make model larger, it will get better results.
Yes, we do.
But it's not the belief, it's that how you make it, how you actually deliver this vision, this scaling that matters.
Nobody has ever said what you just said to me. And I have worked with, like many, many highly cited and quite boundary breaking researchers like yourself. But no one has ever said that thing, like in the beginning, it can be lonely.
Yeah, it has to not be lonely. So another example is like mystery of experts.
Yes.
So MOE model, right now every company is using it. But when we first apply MOE to transformers, to large models, I there are just 4 or 5 people in the world believe in that. Everyone else is against it.
Wow. There's lots of things like that though.
Mm-hmm.
I think that is probably quite typical of scientific progress that, and the best example, that there are so many examples of this, right? Where scientists historically have been called anything from blasphemous, insane, and, have been persecuted for having, right? Like for having beliefs, right? But like,
yes.
And this may, maybe it's obviously not the same as
that. I was persecuted by promoting this kind of MOE actually.
Really?
Yeah.
What people said to you, like, no, this is wrong, or?
At that time, the common belief is that dense model is the best, right? And if you dare to do a fair comparison between dense and sparse, dense versus MOE, it's kind of like you are not cultural fit. You're doing it in a competitive way. You are too competitive.
That's crazy. And I think
you are not inclusive enough.
Yeah.
There are a lot of reasons, a lot of ways to prosecute you if you do something like is less popular.
Yeah. And this leads on to a really interesting point actually, because you no longer work at Google right now.
No.
Right? And you had well, actually, I'll ask you, how would you summarize your career there?
I think it's I think I'm like super lucky to be able to work in that group in Yellow Brain, because previously I was just a regular PhD student, right? And I look for jobs so that I can support myself.
Wow.
But I'm fortunate enough to work with the brightest people in the world in this area.
That's crazy.
Yeah, I think that is super lucky for me.
It's like a real, and people, there's a difference between, one of the things I'm not a fan of personally is when people say like, oh, you deserve this, right? Like what I like to think about is if you earn something, like you earned this, right? But you earned your spot there, right? The work you did, the hours you put in, and you said you worked multiple jobs when you were doing your PhD.
Yeah.
Which was your worst one? Which is the worst one?
Oh, during my PhD, I was just like, I do a lot of like eBay things.
Oh yeah. Okay, you gotta hustle.
Yeah, it's just like trying to explore things, and I also write books for interviews.
Wow.
So that people can prepare the interview better, so I can make and I can make some money. Out of it.
That's awesome. Yeah. Well, clearly you interview well. Clearly you interview very well because you got the job there, right? Clearly. But also, I think people don't understand how much of especially like if you want to climb the ladder in Google or Meta or OpenAI, like any of these companies, right? It can be quite it's an organization. It is a corporation, and it is not free of the, like necessarily that means some of the political aspects and the bureaucratic aspects of being in a corporation are there, right? And you have to climb the ladder, right? And that requires a certain set of skills.
It really depends.
Yeah.
So I think, especially in Google Brain, as long as you do good work, those ladders are just the outputs.
It's aristocratic.
Yeah. And people, as long as you focus on inputs, then those will come with you by nature. So
which is good.
Yeah, I'm not too into the ladder part. I think what is most valuable experience during that time is that I can sit next to those brightest scientists in the world and see in close range how they think.
Do you have any like particular, like who was, maybe like some of the favorite people that you worked with, like brightest people maybe?
Yeah, like Justin Long and Quadler, Zifeng, Those are like the pioneers in this field.
That's
And like so everyone has their own characteristic.
yeah.
They are not ordinary people. They have their own temper.
Yeah.
I say. And they work things like out of ordinary.
Yeah. Well, because they are out of the ordinary.
But they are authentic people.
Oh yeah.
I mean, you have to be very authentic to understand things deeply, and then we can be innovative. So forget about anything else. So for example, I don't want to put the names, but many of them, like, they don't care about money at all. They have debts. They have people trying to collecting debts from them because they forget to pay the bill. They are so focused on those research.
Just driven.
Yeah, they are just immersed by driven by the research aspects. There are a lot of like true scientists because like they have a very good TV show, True Detectives. Those true scientists are just like those true detectives.
Season 2.
Season 1, season 2.
Oh, season 1 with Matthew.
Yes.
Yeah, what a great program, by the way. Like, shout out to that program. It was unbelievable.
Yeah.
That's such a great comparison. Like, they are strange people, right? Like, well, they are.
I'm not saying that's people say have their own characteristics.
The characters in True Detectives, right? Like, Matthew McConaughey, his character is a very complex character.
Yes.
But you find this in scientists that they are. Anybody that does things out of the ordinary, often, like you said, they're very complex people, right?
Yes.
And they may not seem complex, but the way that they perceive the world is often very different to
Yes.
other people, right?
Yes.
You know? Yeah, and I think maybe that's
That's what made them unique. Yeah.
yeah, maybe. But like, okay, so let's talk about why do we leave Google?
Because I would believe like, so it's actually in the ImageNet time, like the cost of training a very good state-of-the-art ImageNet model was 5 million in 2012 or 2014-ish. But with a couple of years, with like 5 years, the cost of training such a model reduced to $50, $10.
Wow.
Because of the innovation algorithms, cheaper hardware, all contribute to this. Because a lot of cost for training a state-of-the-art model is just the research.
Yeah.
It failed 100 times or 10,000 times, and here you have the experiments.
Yeah.
But once you already reach that level, like at that time, it's like superhuman image classification capability. Yeah. It's just like today we are saying AGI or superhuman cognitive activities. It's something, right? So at the beginning, we need to invest so much to make sure achieve superhuman capabilities. But after this criteria is met, then we can productionize it. We can make it industries.
Yeah, we can have impact.
Yeah, we can make sure everyone can use them.
Yes.
And I think that's the same applies to GPT or large language models. So the GPT-5 is much smaller model than GPT-4.5, like 10 times smaller. And I'm not saying like the scaling law stop to work. I'm saying that in order to reproduce the capability of GPT-5 or GPT-4, which should be good enough for a lot of tasks.
For most tasks.
For most tasks.
Yeah.
The cost of reaching this capability or reproducing this capability would decreasing over time.
Yes, yeah.
For a lot of innovations. So I think it became a time to make training of those models a commodity.
Exactly.
So it's not the model becomes a commodity. Model already a commodity.
Yeah.
Because of the API access, because of Gemini, because of ChatGPT, because cloud.
Think how many companies are effectively wrappers via APIs of those models, right?
Yes.
Like it's already a commodity.
So the model already a commodity, but what is not a commodity right now is the training of those models. Yeah. So how do you make data into a model? So that part is still not a commodity, but the fact it could be, potentially could be, so for example, DeepSeek, they can have a very nice model in $5 million.
Yeah.
And with very capable people understand the tech deeply. And they are not inventing any of those algorithms. They are not inventing any of those more fundamental algorithms.
Yeah,
they have a lot of innovation.
They're already out there, right? Like
but they can reduce the cost of training to $5 million.
Yeah,
and I think we can continue this trend. to train a trillion size model with training token with less and less amount of money, with less failure. So if you look at the industry, like $150 billion was invested in GPU spendings. Like companies, their capex spending is like this company is 70 billion, that company is 80 billions. Like in combined, hundreds of billions of dollars go to GPU.
Did you see it came out about NVIDIA the other day? That I think you may know what I'm going to say, but it was like there was one company responsible for
I just too.
Yeah. It's not verifiable, but there was one company that was responsible for like a third of their
revenue. Yes,
that's crazy. Like,
yeah, that's crazy. Assuming like half of the compute would be used for inference, and the other half would be used for training.
Yeah,
but after all this investment, if you look at the most successful startups, their revenue is like 100 million. If you have 100 million revenue, you are superstars.
Yeah.
So that's a huge gap, right? Hundreds billions in the investment and hundreds millions in revenue. That's a huge gap. So still the research, the experimentation took a lot of money. So there's a way, I think there's a chance we can have a very successful, reproducible recipe to train these large language models. No matter it's pre-training using existing open source models, so that we can do some post-training, or we can do pre-training from scratch. But there's certainly an opportunity where we can just replicate the success of internet classifier, right? We can make this training of large model really, really cheap.
And you're talking about we're going from like $5 million to a language, no?
Yeah, $50, $100.
At the time, by the way, when that came out about ImageNet being trained for $5 million, what were people's reactions?
The progress has been made so rapidly. And there would be, and after that, right, there are a lot of computer vision startups take off in successful application in a lot of areas, like cybersecurity or like
autonomous driving.
Yeah, autonomous driving.
Because those companies came around basically a few years after ImageNet,
yes,
right? Like,
yeah, after we solved the ImageNet problems, the vision was largely solved.
Yeah. It's also like a really quick side note, because we're in San Francisco.
Yeah.
With the Waymos everywhere.
Yeah.
For anybody that 99.9% of people watching this will know exactly what a Waymo is. But for those that don't know, it is a fully autonomous taxi. And you get in with no driver. But the companies like that, they came around after this type of thing, right? So yeah. So it goes to show like, the impact, I guess, again, right?
Yeah. So if you want to do like an analogy, so public large language model could be just like electricity. Yeah. You get the electricity from the grid.
Yeah.
But people still need solar panels. Right. They can still generate electricity by themselves. You don't have to get the electricity generated by grid or big companies.
I see.
Or the other way to say is like superhuman capability has been around 1800s, like with trains. That's much faster than human, not much faster than horse. Yeah. You can get from point A to point B by taking a train. So fast transportation becomes a commodity at that time. But people still need cars.
Yes, they do.
To get the last mile.
People still ride horses.
Yeah.
No, but I totally like.
Right, so people still, you can get great service, great superhuman abilities from big companies, from public AI. But if we make the model training a commodity, people have the freedom to drive their own car or generate their own electricity.
And right now, with the current setup, I don't think it is a good thing for, like the big four, like whatever, like OpenAI, Meta, Google, Anthropic maybe even as well. But like, maybe like, okay, OpenAI are doing more open source work. They had OSS, the models that released recently, and his DeepSeek actually, I think as well, forced those companies, right? Like, it forced them,
yeah,
because they came out on DeepSeek and everybody lost it when that happened, right? Like, did people lose it in Google when that happened? Were they like, what is going on?
In Google, people are very optimistic.
Yeah,
so they came. Okay, Google's general training is cheaper than DeepSeek.
Yeah. Oh, yeah. Fair. That's a very good point. Yeah, that's a good point. But I know that I know that like the public
Yeah, the public reaction, it's a good thing. Like, so it drives more innovation.
Yeah.
So just like ChatGPT comes along, Google become panic, and then they react with Gemini, and other company just put a lot of investment into this area.
Yeah.
Otherwise, like, before 2022, it's pure research.
Yeah.
So yeah, our expectation of doing this kind of large language model work is just like, oh, we can have a blog post, and we can get people talk about the work on Twitter. That's all we need. That would make us very happy.
And but the point is like so we're talking about commoditizing the training of models, right? So people can quote unquote drive their own cars, right?
Yeah.
And that, but I suppose to put like, okay, is that really in those companies' best interest, right? And that's the thing, right? You know, maybe it is. Maybe there are ways to look at it where it is in their best interest, but you know, it's not like priority number one, right? Is to like completely open source or to make this as available, democratize this, as much as you want, right?
Yeah. So, but companies nowadays, they have no other choice to create a wrapper around OpenAI and others, because the return of investment for training is so small.
Yeah.
It's not because like if training a large model costs too much. It's just like the experimentation, the know-how costs a lot of money. And especially nowadays, the AI engineer, AI researchers become more and more expensive.
Oh yeah.
So that is the reason people still use a lot of OpenAI OpenAI API instead of training their own model. But it doesn't mean like with this model training community makes OpenAI or Gemini less popular. So we are still in a growing market, and people still use electricity from grid.
Yeah.
Nowadays, right? So those are real commodity provider.
Yeah.
It's just like with model training as a commodity, people can customize things, because public API models, they are trained on public data. They don't have access to most private data.
Yeah, the proprietary data.
Yeah, and then there's a joke like every startups are a wrapper of OpenAI, and every large models are a wrapper of Reddit. They train on similar data source.
Well, you can see with all of the models together, right? Like, but correct me if I'm wrong. Actually, you may be able to say, you may not be, but so like OpenAI trained lots on Reddit, and XAI trained lots on X, Twitter, and maybe Google used a lot of YouTube as well, like the internal stuff, and then Meta obviously used the data from the data they have from those things. So
actually, it's very hard to use internal production data, because a lot of the regulations.
Yeah. Oh, yeah. No, of course. Yeah,
so I don't think Google can train on YouTube data. Unless users especially agreed on.
Yeah. Well, this is the thing. Like there was like what was it? I can't remember which company it was. It was one of the big companies. It wasn't Google. It was another company. But they had this. They were like, we're just gonna, we're gonna train on your data, and it was like baked into the model, but you didn't ask, right? And that was like an outcry from it before. I can't remember which company, but that's a good point. But on the democratization piece, right? Just explain in your own words to people, what does it actually mean to democratize AI?
It doesn't mean that you become less dependent on public grid electricity. It actually means like you have your own data, and you want to make the best use of this data. And so far, the universal algorithm to make good use of data is through backpropagation, through neural network. So if you want to get the best out of your existing data, then it's better you train a model. So you can use pre-trained open source model, which has a lot of public information, like a general prior knowledge about the world, and you continue to train on your personal data. So it knows your habit, it knows what tool you usually use, it knows your preference, and also like allows you to tune the model to your favor, right? You want it to be a conservative chatbot, you can make a conservative. You want to be a liberal chatbot, you can make a liberal.
And we see this already,
Not yet.
Well, no, just in terms of like not like this, but like the woke models or the non-woke, like XAI will say it like It's like
Yeah, let's say I really might train a lot on Elon Musk data. Like,
exactly. But yeah, sorry, carry on.
it's all about how you make good use of your own data for your own business.
Yeah.
Because inevitably, model or training of large language model is make good use of the public data.
Yeah.
And there are just like way more private data out there in the world.
Yeah.
Not just like Reddit or websites.
It's like so much.
It's
right?
so much.
Yeah.
In various different ways, different forms,
That's crazy.
structured, unstructured, different modality. You can think about it. It's too much there.
Yeah. It's wild. Like
Yeah.
if you think like the frontier of AI models, if you think about the data we have access to, like the public data, and then you unlock all of the private, right? And how that can change the use cases. And like what you're saying, right? Like the training being a commodity, and you manage to unlock that in one way, the impact is huge, right?
Yeah. And people have been talking about this for, I think, a couple of years already. There are a lot of words like fine-tuning, reinforcement learning, a lot of technology trying to achieve this direction. It's not easy for sure, right? But it doesn't mean that this is not a good direction. It's still a very difficult direction to pursue. It requires a lot of research and experimentation to make it a very universal and reliable training recipe.
Yeah.
But it will be there, just like ImageNet.
Yeah.
It might take a couple of years, but it will eventually be there.
The harder the climb, the better the view.
Yeah.
Right? Like sometimes, right? And you know, look, I know you can't like you can only say so much about where this technology might go because we don't know is the reality, right?
Yeah.
And you don't want to promise too much because like we just do not know. But if you have this universal training, recipe, right? How much easier does that make it for people to extract value out of these models?
So suppose when all the companies API is like has limited context window.
Yeah.
1 million tokens, 10 million tokens.
Yeah.
But if you look at your Gmail account, right, you have like 10 gigabytes or like 100 gigabytes of data. And your photos and your if you are a tech person, you will use terminal.
Yeah.
You have a lot of terminal history. You have a lot of your phone call history, the way you talk, the way you interact, the favorite tool you use. If you use Emacs or Vim or Seed versus whatever tools. And those are the data you have. And you can try to leverage those data. So it's not just like enterprise might need their own customized model for every person or for fanboy of tech, for tech fanboy. It's a great way to personalize it.
Yeah.
It's just like Linux, right? You have Windows, everyone will use Windows. But if in Linux, you can customize whatever way you want.
One thing, and I will just say, by the way, as we kind of like, we kind of round out on these points. And this is from somebody. I'm not an engineer, right? Obviously, right? I mean, you can tell. Well, I'm not an engineer or scientist, but one of the things I get frustrated with sometimes is when you're using a model and you expect it to, this is just expectations of anything, but you expect it to remember or have the context of your tone, how you speak. If you want to, I can't ask GPT to put posts out or write emails for me because it is so evidently not me, right? And that's, one of them. But if you're a company, you have an identity. If you're a brand, you have like an identity. And, I suppose it's one of the big things, isn't it? Like having models that you can train on your own data, and you have this training language, this recipe to be able to, to have your identity, I guess. Because I think that would allow a lot of companies to like generate a lot of value, like, right?
Yeah. So that would be the general trend. It's just like the solution space is huge.
Yeah.
Yeah, there are a lot of ways, like even big company can do it, possibly by making the memory or context infinite large. Or you can just do the standard backpropagation way so that you can bake those data into the model weights, into the parameters of your neural network.
I have one more question for you, right? Before we finish this out. And by the way, this has been like just really awesome to have you here. I really think in this as well.
Thank you.
I have one more question to ask. Why do you think, or why is open source so important?
It all the opposite. Imagine a world with not open source model, right? So it becomes the toys of those big corporations. That OpenAI has one, and then the other companies they want to have their own toy, their own copy.
And Mark Zuckerberg has one, Sam Altman has one, Elon Musk has one, right?
Right.
And so on and so forth. And that would, look, I personally do not think a good world is where technology billionaires make decisions about how society would work, right? Because so word2vec was a really interesting thing because it fundamentally misunderstood elements of social science and how those were baked into models, right? And that was one of the problems with it. But, I can't imagine a world where there was no open source, right?
Yeah, we cannot say those billionaires or like mega billionaires are bad person.
No, of course.
No, we are not saying like Elon or Sergey are bad person. But it's kind of dangerous to society. Like this super intelligent, like those AGI belongs to only a few people.
Yeah. It should belong to everybody.
It should belong to everybody.
Yeah.
Let's see. And in reality is right now, they're literally owned by a few, very few people, like 7 people in the world.
And if you can contribute to making those things accessible to everybody, that is, if there's a worthy mission, that is a worthy mission.
Yeah.
Right?
Yeah. Because like the safety of the large model is not just the safety feature inside the model itself, but also the owner of this large model.
As we've seen, right? But Yanping, look, it's been an absolute pleasure. Really, I have so as we do is tradition on this podcast, we will always ask you to ask a question for the next guest. You're the first person on this, right? Like you're episode number 1, right? So we don't even have a question for you, so I'm so sorry.
Yeah, no, it's
but if you could ask one question for the next guest, what would you ask them?
So the guest asked also researcher.
Yeah, researcher. Yeah. This is a scientist. Yeah, the next guest is.
Okay, so I think my question would be like, how do they? So in this kind of like very chaotic, very noisy AI world right now, right? Because you would hear people get 100 million salary from Meta. You would hear someone raise 1 billion. And what is the decision making for you to decide whether you want to pursue your own research direction or work on this kind of large language models?
That is fantastic.
Yeah, or generative AI in general.
That's a really fantastic question. Well, everybody, thank you so much for watching. Yanping, I really mean this, right? Like that was.
Yeah, thank you very much for having me.
Yeah, really, really awesome. And guys, we hope you enjoyed it. Thank you very much. We'll see you soon.